This week, Lara looks at the elemental solution to cleaning up carbon emissions from aircraft.
We travel to the remote Faroe Islands to look at the latest ways to harness tidal energy.
It's sort of like kite surfing, but on the water.
If it moves, it's a controller. Paul's en route towards more accessible games.
If I just raise my eyebrows, I'm making the car jump.
And we look at how generative technology could revolutionise the movie-going experience.
It can make approximately 52 quintillion versions of the film.
About 100,000 flights jet around the world every day. Flying accounts for 2.5% of all carbon emissions. Now, that might not sound like much, but if aviation was a country, it would be among the top 10 most polluting nations in the world, and its impact is expected to rise.
Now there's a global race to get clean aviation off the ground. And some companies think they're close to cracking it.
Pretty soon, passengers flying in zero-emission aircraft.
But how did we get here?
The new machine is called, optimistically, the Flyer.
We've come a long way since the Wright brothers' first flight in 1903.
That day they lifted the world into a new dimension.
Then we achieved bigger, faster planes. Great, but that's also how we ended up with all these emissions. Jet engines burn kerosene, which releases carbon dioxide, one of the main greenhouse gases causing climate change.
The industry faces an enormous challenge to clean up its act, and that means coming up with new fuels. So let's take a look at some of the options. There are biofuels, which are made out of things like plants or vegetable oils, but they still produce some harmful emissions. Then there's electric, but although batteries are getting far more efficient, the size that you'd need to power a passenger jet would be way too heavy. And there's one potential solution that's getting people really excited: hydrogen.
Hydrogen fuel cells combine hydrogen and oxygen to create a flow of electrons around a circuit to power a motor.
And as we all know, hydrogen plus oxygen equals H2O. The problem is
we can't do much about the fundamental properties of hydrogen. Volumetrically, we need to compress it to get sort of in the ballpark of not quite a third of the efficiency of fuels that we use. That means that we need often very large, very heavy tanks because they need very thick walls to deal with the incredibly high pressures we need them at. What you end up with is an aeroplane that can't have any passengers in.
This is the challenge faced by 20Apr, one of several companies working to make hydrogen-powered flight a reality. They retrofit existing planes with hydrogen engines. The company had several successful test flights with this plane last year.
In the original frame, we would be able to fly about 19 passengers.
it looks like a lot of kit in there. How would you fit in 19 people?
Yeah, so in the retrofitted configuration,
created in these small layers, so you have to build up your layers to create the power to take off an aircraft.
This engine could almost provide enough power to get you from London to Glasgow, but not quite.
If you wanted to scale it up for international flights, would you just make the same thing bigger, or is it a totally different exercise?
It is scalable until a certain power, but then we'll have to change technology. Getting this high power density system that will allow to have a lot of power, but minimal weight to be integrated on an aircraft is really a challenge.
And that probably means completely redesigning the plane.
everything will be shrunk. Some parts of the engine of the fuel cell will be sitting inside of the nacelle. And also the storage tank, which is going to be probably the largest piece of equipment we will actually bring outside. Okay?
Right.
So either on the side of the fuselage, or we will hang it on the wing.
Making everything fit isn't the only challenge, though.
We need to have the maintenance and repair organization. The whole process needs to be certified. We need to provide the hydrogen infrastructure to the aircraft.
20Apr has a plan for that.
In its vision, hydrogen would be produced on site at airports using renewable energy before being processed and transported out to the plane.
But what about the cost of all this?
At the moment, liquid hydrogen is significantly more expensive than conventional jet fuel. But backers of hydrogen planes believe it will eventually become cheaper than traditional flight. 20Apr isn't the only company racing to reimagine air travel, though. Aerospace giants like Airbus and Boeing are also developing hydrogen planes, but there are still questions over how sustainable they'll actually be.
We're going to be using some fairly exotic materials that are very energy intensive to arrive at. What energy are you using to build the fuel cell? What materials are you using? How much energy are we sinking into this technology to get something out?
20Apr has the backing of the UK government and big investors, and has over 2,000 pre-orders from airlines. So there seems to be significant belief in hydrogen despite all of the challenges. But what I really want to know is,
are we going to be able to jet off to Spain anytime soon in a hydrogen plane?
History shows that you need to start small and grow big.
And that growth would take a while, but if this could be scaled to the largest of planes, then the difference to emissions would be jumbo.
You know, it sounds like if they can get it right, hydrogen planes could be a massive deal.
Yeah, it's as much about the infrastructure, though. They've got a lot to do.
Right, okay, noted. Okay, well, we're going from the air to the sea now. You might not think of the world's oceans as a great source of green energy, but when you...
Murray has been to the remote Faroe Islands, which are between Scotland and Norway, to see what they're doing to help harness renewable energy.
Rugged and remote, the Faroe Islands are an isolated archipelago found in the North Atlantic. Powerful currents flow around its 18 islands. And in this sea channel, called the Vestmannaeyjum, mechanical creatures lurk beneath the water's surface, called dragons. Designed by Swedish marine energy firm Minesto, it's among a wave of new technology that hopes to revolutionise tidal power.
This huge yellow thing behind me is a tidal kite. It looks a bit like a glider because it's designed to fly through the water, and once it's installed on the seabed, it will be generating electricity using the current that flows through this stretch of water.
Weighing 28 tonnes and with a 12-metre wingspan, the newest Dragon can deliver 1.2 megawatts of power.
It's sort of like kite surfing, but on the water. So we tether it off to the seafloor, foundation on the seafloor, and then it flies in a figure of 8.
As underwater currents flow by, the kite's wings generate a hydrodynamic lift force, spinning the turbine and generating electricity.
This design's very different to other types of tidal.
This is actually a very small tidal turbine. We've designed the system as such to be maintenance friendly, and that you simply just tow them in, replace modules, and then put them back in. We've also, over the years, removed more and more components from the system and fit them on shore instead. The less components you have that could become damaged, it's easier to access it, and it's much cheaper also.
It's the gravitational pull of the moon, and to some extent the sun, which gives the tides their rhythm. And unlike wind, solar or hydro, tidal power isn't reliant on weather. While tidal barrages have been around for decades, their cost and the ecological impact has been a barrier. Now, from the Scottish Islands through to Canada, a new generation of tech firms have introduced tidal stream turbines.
Ocean energy is still largely untapped, so what are the barriers that have prevented it from taking off?
It's a relatively small and new industry, so very few machines in the water, and then you have to compete with wind farms and solar PV, etc. We're now addressing a resource that's so much larger, so we're opening up a market that didn't even exist before.
If all goes to plan, there could be arrays of subsea kites around the Faroe Islands, installed in groups similar to wind farms.
So this machine here, that's the first utility or the array device. There will be many of these in parks, or arrays as you call them, around the world.
The Faroes aren't connected to any other country's power grid, so it has to be self-sufficient. And in the past, it relied heavily on oil imports. Now though, it's going fully green. And this battery station helps to regulate electricity supply.
We have the biggest battery, I think, in the Danish kingdom. We don't have any subsea cables to neighboring countries. So we need to maintain the stability of the power system at all points in time, on a millisecond level.
Much of the country's power will come from wind, hydro and solar. But that's also where its experiment with tidal energy comes in.
It's predictable. We know exactly when it's there, 100 years ahead. If we install tidal turbines in different spots, we will have a baseload generation from tides. And that is extremely valuable. If we can unlock the potential, it can really dramatically change the energy mix in the islands. Maybe 30 to 40% of the annual usage in the islands could be provided by tides.
Now this dragon has begun to fly and is sending energy to the grid. It's just one machine, but potentially a big leap forward for harnessing energy from our seas.
I used to work the whole day when I was pregnant. I wouldn't take much rest. I remember being thirsty all the time and out of breath.
Acabamos de llegar al lugar donde va a comenzar la búsqueda del migrante desaparecido.
So from where we're at right now, we can see from left to right and right to left, a heavily wooded area denotes the border between North